Welcome to Study Loop.
The task in this problem is to solve three subparts and the given reaction is H2. Now it will be CO3 and it is here aqueous. So it is getting converted into H2O and this is in aqueous. Now it will be here plus CO2. Again this is in aqueous. So the reaction progress is monitored and the concentration of carbonic acid is recorded as a function of time. So the concentration of carbonic acid is plotted as a function of time in the graph, and from the graph the initial concentration of the reactant can be here written, that is at t is equals to 0 seconds the value of A naught will be equals to, it is the initial concentration of the reactant and it will be 1.6 molar, and now we can mention that half of the initial concentration will be, it is A and then it will be naught, then it is divided by 2, so this value will be 0.8 molar, and from the graph we can see that the time taken for 1.6 molar of the reactant to fall to 0.8 molar is 0.50 seconds from the graph, and hence the value of T half will be equals to, because according to the definition of the half-life of the reactant will be, it is 0.5 and then it is 0 seconds. So we have obtained the answer and we can put the answer inside the box in order to highlight it, and then we will discuss the second part of this very problem. And here we are given that the reaction is first order in H2CO3. So the integrated rate law for the first order reaction will be, it is ln and here it is A. Now it will be here T. So this value is ln and here it will be A. Then it is here naught minus it is K times T. So this will be our first reaction, and A naught is the initial concentration of the reactant A, and A of T is the concentration of reactant A after time T has passed. Now if we substitute the value here, then it will be ln and here it is A naught, then in the denominator it is divided by 2 and this value is equals to ln and here it is A naught and then it will be minus times K multiplied with T half. So if we simplify this expression, then the value of K will be equals to, it is here ln 2 and in the denominator it is going to be T and then it will be half. So if we substitute the value here, it is 0.693, then in the denominator it is 0.50 and then it will be seconds. So this is approximately 1.4 second inverse. So we have obtained the answer and we can put this answer inside the box, that is the required rate constant of the reaction is obtained. Now we will proceed towards the third part of this very problem, where we can mention that the value of ln and here it will be A of T. So let's write this one as A of T and this is equals to ln and here the initial concentration is 1.6. Now it will be minus the value of K, which is 1.4 second inverse, and it is multiplied with time, which is given in the problem as 5 seconds. So if we simplify this expression, then it will be equals to, it is negative 6.53 approximately, and here it is ln and it will be concentration at time T. So the value of here A, that is the concentration at time T, will be equals to E raised to the power negative 6.53. And this value will be here approximately, it is 0.0014. So we have obtained the answer, that is the required concentration of H2CO3 after 5 seconds will be, it is H2 and then it will be CO3 and it is equals to 0.0014 and then it is molar. So let us put the answer inside the box, and that's all for this very video.